Good morning, students. I hope all of you are doing good and I hope all of you are studying physics. Welcome to a new lecture. So today we are going to talk about Young's double slit experiment, a very famous experiment as far as the future of physics was concerned, a very important and very significant experiment. Right, so this experiment was performed by Thomas Young. He was a scientist, and now before this experiment, we believed, not we, but all the scientists, they used to believe that light has a significant particle nature in it, right? So before that, Newton's corpuscular theory was very much prominent, and we all thought that okay, the light has particle nature in it, right? Now what this experiment did, right? So what was Thomas Young's idea? The idea was very simple. The idea was he took a monochromatic source of light. Monochromatic source of light means a light source which have light of only single wavelength, right? So he took a monochromatic source of light. Let me call it this source S, right? This is monochromatic source, right? And then what he did, he passed this light to double slit, right? He took a cardboard, he put two slits, right? Now these two slits are very fine. You have to understand, very fine slit. They are so fine that these slits can be comparable with the wavelength of the light. These slits have the dimension comparable with the wavelength of light. So that fine slits, right? Very, very small, 10 raised to power minus 7, 8, 9, 10, right? So that dimension kind of slit. So that means only one particle can pass at a time, right? So that small slit, right? And a very far distance away from this two slits, he put a screen, right? He put two screen, right? Okay, he put two screen, right? Normal human being, what he will actually, before the experiment, what are his expectations? He will see that okay, light has particle nature, agreed, right? So what will happen? The light, okay, let me call it that he took a red light, right? So okay, so he will see, okay, light will pass through the slit, right? Light will pass through the slit, right? And what will happen? You're supposed to get, okay, you will get okay, something like this, right? Or iska bhi, you will get something like this. Yes or no? In the screen also you are supposed to get two red line, right? And rest other, it will be dark, right? It will be dark, right? That is something he actually, he or any other person will actually expect, right? Because till now we are discussing that okay, light has particle nature. This is something which we all expected, right? But very, very astonishingly, things were pretty different, right? So what actually happened? He saw that when he did that, he just saw this kind of pattern, right? He saw a pattern like this, right? That means he saw a monochromatic, यहाँ से आपका monochromatic light गया, right? So here there are two slits actually. We will explain what happened, how this is happening, right? So okay, so he saw there was a pattern like this, as you can see in the screen, the pattern like this. That means at the center, right? So let me use different colors so you can understand. At the center, this is the center part, right? At the center there was a bright spot. There was a bright spot which is very unlikely to happen. Yes or no? Which was very, very unlikely to happen. He saw at the center there was a bright spot. So it was very weird, like how is this happening? How we are seeing a bright spot, or I should say actually it's called a fringe. We will talk about it later in the video. But he was able to see a bright spot at the center where no way the light can go, right? So he was very confused. Now what happened actually, right? Okay, one more thing, this experiment was done in 1801, right? 1801 this experiment was done, right? So before that time we believed that okay, light has particle nature. So it was pretty strange, like how is this happening, how can I get, you know, a bright spot at the center of my screen, right, where there is no there is, which is very unlikely, right, to see, right? So he was very confused, right? So okay, and then after that he saw, after bright spot there was a dark spot, right, and then a bright, then a dark, right, and so on. You get a pattern, alternate dark bright fringes, right? So he was, so that was the experiment, right? That was the experiment. So he was pretty amazed to see the result, right? So okay, so how the people were able to interpret that, right? So okay, now again we know that we have studied Eigens principle, right? We have studied Eigen's wave theory. So according to Eigen, that your light is not a particle, but light is actually a wave, right? It's a mechanical wave, right? So that's what Eigen's, you know, Eigen's wave theory says, right? So okay, in order to explain this phenomena, we had to go back to Eigen's theory, right? Eigen's wave theory, right? So later on, this experiment was explained, this phenomena was explained with the help of Eigen's principle. Okay, so what was how he was able to explain? So let me just very quickly make the top view, right? Okay, so आप लोगों ने देख लिया, it was a normal view. I will just take the top view, right? And let's take the top view and let's try to understand what is actually happening, right? How I can explain this with the help of Eigen's, you know, wave theory. All right, so basically, okay, so I will be a, so there is this slit S1, right? This is your S slit, right? There is a monochromatic source here, right? This is the source. Let me just write it here. This is the monochromatic source, right? This is monochromatic source. All right, now what happened? Now the slit was something like this, right? Okay, this is the slit, this is your S1, this is your S2, right? And then the screen, let's say screen is somewhere here. Okay, great. Now screen is also done, right? Okay, now let's see what happened. Let's try to understand this phenomena with the help of Eigen's wave theory. So according to Eigen, every source, for example, you were having a point source, we will there, the point source will emit wavelet and then wavefront, yes or no? So obviously I'll just draw the wavefronts, right? So these are the wavefronts, circular spherical wavefront, right? So remember, these are your line source, very important. These are your line source, not a point source. You have to imagine it as a line source, right? Okay, all right, great. So your wavefront is coming like this. Obviously one wavefront will be going to hit your slit S, right? So from slit S will actually behave as the new source of disturbance, yes or no? Slit S will behave as new source of disturbance. I hope everybody agrees with that. All right, so what will happen next? Okay, slit S will emit secondary wavelet, yes or no? Slit S will emit secondary wavelet and hence the wavefront, right? So it will go like this, right? Okay, now one of the wavefront will hit second, slit S1 and S2, yes or no? And again, now by Eigen's wave theory, S1 and S2 will act as the new source of disturbance, right? And they will also emit your tertiary wavelet, yes or no, right? I hope everybody agrees with me, right? Okay, all right, so what will happen? Your S1 will emit wavefronts, right? I hope everybody agrees with me, right? Yes or no, right? Very similarly, let me okay, your S2 will also emit what? It will also emit wavefronts, right? Yes or no, right? And they will move forward. And they will move forward and end the screen, at the screen, we will see at the screen, we will see there will be, okay, there at the center we will see there will be a bright spot. There will be a bright spot, right? So basically we actually say this as your bright fringe, right? But at the center you will say, okay, for time being I'll just say it is a bright spot, but actually it's a fringe, right? It is actually a fringe, right? Okay, so you will see a bright spot, yes or no, right? After bright spot, what will happen? You will see a dark spot, right, on both the direction, right? You have to understand here. So let me just, yeah, so this will be, so at the center you will see a bright spot, then dark spot, then again bright spot, then again, yeah, you will see the bright spot, then again dark spot, then again dark spot, yes or no? So you will see a pattern like this, right? Now why is this pattern coming? यहाँ पे आपको समझना है why is this pattern coming. You see, in the previous video we talked about interference of wave, yes or no? Interference of wave, and I hope everybody must have watched it, right? So in the previous video we talked about interference of wave, and in the interference of wave we talked about two terms. We talked about two terms, right? Number one was constructive interference. Constructive interference. Second term was destructive interference. Yes or no? Right? Okay. Now I'm sure all of you must have saw wherever there was constructive interference, right? Wherever there was constructive interference, we saw a bright spot. Bright spot, right? Bright spot was, you know, visible, and here it was dark spot. Yes or no, right? So wherever there was constructive interference, we had bright spot. Wherever there was destructive. So what do you mean by constructive interference? It means, for example, you have a wave. Let me try to explain. Let's say you have a wave, right? And this wave is being added with another wave, right? Now you have to understand, normal, whenever we talk about a wave will be having the upper part, right? Upper part is what you call as crest. You will call it crest, right? C-R-E-S-T, crest. The upper part of the wave is known as crest, right? And there is one more part, that is the lower part. We call it trough. Yes or no? We call it trough. Yes or no? I hope everybody agrees with me. Trough, right? The down part is what you call as your trough, right? Okay, now when these two waves are added, right? So the resultant wave, you have to understand, the crest is being added with the crest, right? So basically you will get a higher crest. Yes, the trough is being added with the trough, you will get a higher trough, right? So in entirety you will say that the addition has benefited this wave, right? So now because of the addition of these two waves, what happened? Now the amplitude has been increased, right? And in the previous video we have, in the previous lecture of interference, we have saw whenever the amplitude of the wave is increased, you will see a bright spot, right? So this is what constructive interference means. When the crest is being added with the crest, and when the trough is being added with the trough, you get a constructive interference and the amplitude is amplified. I hope that is understandable, right? So because of that, what will happen? The intensity will increase, right? And you will get a bright spot, right? I hope that is clear. Very similarly, let's talk about dark spot. What is happening in destructive interference, right? So okay, so let's say you have, and again, a wave, right? Let's say you have a wave, something like this, okay? And you are adding this wave with another wave, but this time the wave is of different, character, right? Okay, now this time what is actually happening? The crest of the first wave is being added with the trough of the second wave, right? That means the first amplitude is like this, the other amplitude is like this, at the end they will kind of nullify each other, yes or no, right? So as a result you will see that they will kind of nullify each other's effect, and you will see a wave with a less amplitude, or they will each actually at the end of the day they will cancel each other out if the amplitude of both the waves are correct, right? Same, right? So at the end of the day they will cancel each other out, or they will have an amplitude of low amplitude, right? Okay, so what does that mean? It means amplitude is less, and we know amplitude is directly proportional to the intensity. If the amplitude is less, amplitude is 0, then intensity will automatically become 0, right? So this kind of interference is what you call as destructive interference. They have destroyed each other by adding up, right? In constructive, they have constructed a new, a new strong amplified amplitude wave. So because of that we will see a bright spot, and on the other hand we are having a destroyed amplitude wave, so because of which we will see a dark spot, right? I hope that is understandable, right? Clear? Okay, so this is the concept here. So basically let's look back here, right? Okay, now how we can visualize the crest and the trough in this particular case, right? So you guys have to understand here. So whenever we talk about Eigens Principle, right, whenever we talk about Eigens Principle, let me just take you there, right? So there will be a point source, right? And the point source is supposed to emit wavefront, yes or no? They will emit wavefront, right? And I hope everybody agrees with me. So they will emit wavefront. This is the first wavefront, right? Okay, now according to the principle, every point on this wavefront will behave as the new source of disturbance, yes or no? Every point on this wavefront will behave as the new source of disturbance, because of which what will happen? Secondary wavelet will be emitted, yes or no? I hope everybody agrees with me, right? So secondary wavelet is being emitted, right? You can draw this with the help of a compass, right? That will give you better understanding and better accurate diagram, right? So here, if you add all the common tangents here, right, if you meet all the common tangents in the forward direction, then that will be your next wavefront, right? That will be your next wavefront, right? But we have to understand here there is one more wavefront, that is, in the backward direction, right? In the backward direction, yes or no? When I meet all the tangents in the backward direction, right? So basically you can understand it like this, that this is your crest and the back one is your trough, right? So what does that mean? Whenever there is a source, so there will be trough, and then there will be crest, right? Again there will be trough, then there will be crest, right? So basically you can understand it like that, right? It's just a way of understanding things so that you can understand what is actually happening, right? So if this part is clear, now let's go back to the diagram here, right? So now you guys have to understand that there is a trough between every crest. I hope that is understandable, right? Same thing will be happening for the slit S1, right? Same thing will be happening for the slit S1, right? I hope that is understandable, right? So, and that will go, and you have to understand wherever the crust and the trough, the crust and the trough are interfacing, or I should say wherever the crust is meeting with the trough, of a different wave of the slit S1 and S2, there will be destructive interference. Wherever the trough is meeting with the trough, wherever the crest is meeting with the crest, there is constructive interference, right? And you will see a dark and bright spot. Yes or no? I hope that is understandable, right? I hope that is very much understandable to everyone, right? Okay, great. So you're the first one, the in between, the middle bright spot is what you call as your central bright fringe. You will call this as central bright fringe. So let me write that here. The middle one is what you call a central bright fringe, right? Central bright fringe, right? Okay, above that you will call this one, you will call as your first dark fringe, right? It's very similarly, this will also first dark fringe, right? Okay, this is known as your first bright fringe, right? This is your first bright fringe. Second dark fringe, this is second dark fringe, and so on, right? This thing continues, right? I hope that is understandable, right? So I can make you guys, okay, I have a small simulation by which you can understand it more. Let me just take you there. So yeah, you guys can see, here is the simulation. You guys can see this is the line that we were talking about, right? So the waves are coming, and you can see interference is happening, right? And you can see the lines over here. Yes or no? I hope it would have helped, right? You can see the different alternate dark, bright, dark, bright fringes. Yes or no? Right? I hope that is understandable. Clear? Okay, now let's go back, right? So this is what is happening here, right? Okay, all right. So now I hope you can actually make it, right? You can actually write it, right? Wherever, see, you can very simply write it that S is a monochromatic line source, right? Now it emits cylindrical wavefronts, right? It emits cylindrical wavefronts, right? And one of the wavefront is going to strike your S1 and S2, right? One of the wavefront is going to strike your S1 and S2, slit S1 and S2, and now slit S1 and S2 will start behave as new source of disturbance. I hope everybody agrees with that. Slit S1 and S2 will act as the new source of disturbance, right? And also when they will act as new source of disturbance, they will also emit what? They will also emit cylindrical wavefronts, right? And very simply at the next line you can write places wherever the crest of one wave meeting with the crest of another wave, constructive interference takes place, and we will obtain a bright line, or you will call it bright fringe, right? Very similarly, bright fringe is also obtained at the places where trough of one wave is interferencing with the trough of another wave, right? And there will also you will obtain a bright fringe, right? Now places wherever your crest of one wave is meeting with the trough of another wave, destructive interference will takes place, and we will obtain a dark line, and simply we will call it dark fringe on the screen. I hope that is understandable. Clear hai? I hope you guys can write it down in your own words. That would be really, really great, right? All right, so let's move forward and let's try to find out the fringe width of the fringes that we just talked about. All right, okay, so this time I'm going to just make the top view. I will not make the side view, I'll just make the top view. So let's say these are the two slits we were just talking about, right? So these are the two slits. Let me call this slit S1, right? This is slit S1. Okay, yeah, slit S1, and this is your slit S2. All right, great. Okay, so here let's say somewhere at some d distance, here is your screen. So this is the screen, right? Okay, so now the distance between your S1 and S2 slit is actually small d, right? Okay, so let me just make the in between distance. Okay, so what we are going to see, we are going to obtain yeah, something like this. So this distance is actually d, this distance is actually d is the distance between the slits and the screen. So what we are going to obtain at the center, like we just discussed, at the center we are going to obtain central bright fringe, yes or no, and then we will obtain dark fringe, right? First dark fringe, again यहाँ पे भी आपके पास first dark fringe आएगा, and so on, right? So the pattern will continue, right? Now in order to find out the fringe width, what I will we will just assume, okay, there is this far away point where actually I'm getting the nth bright fringe, right? There is this far away point where I'm getting this nth bright fringe, right? Important thing is the distance between this nth bright fringe with the central bright fringe is some xn. This is the distance between my central bright fringe and this nth bright fringe, दोनों के center के बीच में distance, that is actually xn, right? Okay, so how is this nth bright fringe is going to come into existence? Okay, what will actually going to happen? So we can clearly see the waves from S1 would have reached the point, and let me call this point P. The waves from S1 would have reached the point P, right? Very similarly, waves from, or I should say wavelets from S2 would have reached this point P. Yes or no? Agreed? I hope everybody agrees with me. And let me also make one more let me draw one more line from the center of both the slits, right? So yeah, let me draw one more line here, right? Okay, great. So let me call this angle to be theta, the angle between the center line and the horizontal line. Let me call this angle to be theta, right? So we all know that these two waves, so I'm sure you must have seen the previous video of mine, right? So in that previous video we talked about the interference, right? So obviously at point P the waves would have constructively interfere, it would have constructively interfered, right? That's why you are seeing the bright spot, right? So if you are seeing the bright spot, there must be a path difference, right? There must be a path difference, right? Okay, very similarly, so let me just write down the path difference. So path difference कैसे होगा? Path difference is actually higher path minus lower path, right? So okay, so let me just draw a perpendicular from your S1 to this point, right? This is the perpendicular here, right? So this is the perpendicular here. Let me call this perpendicular as some M point, right? Okay, so now from this diagram I can very clearly say that the path difference between these two, the wave fronts that are going from S1 and S2, the path difference, that is the del x, we call it del x, right? Path difference actually equal to, yes, higher path minus lower path, right? Higher path is your S2p. I hope everybody can see that S2p is the higher path minus lower path S1p. I hope everybody is following that, right? Okay, now you guys have to understand here that these, okay, one more assumption is very prominent here. The assumption is that your distance between the screen and the slits is very greater than the distance between the slits, right? Very important. This assumption is very much important, right? Okay, so now you guys have to understand, right? So if this assumption is true, अगर ये assumption true है, right, the distance between the slits and the screen is much greater than the distance between the slit. इसका मतलब क्या है? Basically I'm going to see something like this. ऐसे कुछ होगा. Basically you will see that they are coming from the same line. So basically आपको समझना है, it will be something like this. ये आपको ऐसा फील होगा कि ये कुछ ज़्यादा डिस्टेंस पे है, right, and there is a path difference. So this OM can be considered as my path difference. See, this OM can be considered as my path difference. I hope everybody can see that OM will be, you will feel that OM is actually like the path difference, right, between the, see, आप देखो S1P and MP. S1P and MP are actually almost same path. The difference in the path is actually OM. Yes or no? OM is the extra path difference here. Yes or no? I hope everybody can feel that OM is the extra path that has been traveled by your S2, right? So I can very simply say, okay, this path difference this path difference is actually del x is actually approximately equal to my S2m, sorry, is actually equal to S2m, right? This is the path difference. I hope everybody agrees with me, right? S2m is my path difference. Okay, let's try to find out what actually is this S2m, right? Okay, आपको पता है that, let me use different pen. Okay, आपको पता है this angle is actually theta. So if that angle is theta, this angle will be 90 minus theta. I hope everybody is following, right? If that is 90 minus theta, then this angle will be equal to theta. Yes or no, right? If that is understandable, then I'm sure everybody can agree with me that S2P is actually equal to d sine theta. Just take a minute to understand this part. Again, I'm saying the angle between your S2P and this horizontal line will be theta. Then obviously this angle will be 90 minus theta, right? And very similarly this angle will be theta, right? If that is true, this S2m, that is the path difference, will be equal to d sine theta. Okay, I hope that is understandable. Take some time to understand that, right? थोड़ा time लीजिए, समझिए, right? I hope that is clear, right? Okay, if that is clear, right? Very important assumption is that d is much greater than d, right? For that I can say that the path difference is actually del x, and this del x is actually equal to S2m, and again this x2m is actually equal to d sine theta. Yes or no? D sine theta is the path difference for your nth bright fringe, I hope everybody is agreeing with me. Yes, right? Clear hai, right? So d sine theta is the path difference for the nth bright fringe, right? I hope clear hai, right? Okay, now we all know, before that we know that we are talking about nth bright fringe. Yes or no? We are talking about nth bright fringe, right? And we are nth bright fringe means we are talking about the bright spot, right? So we all know in the previous lecture we have talked about the interference video. In that video we have talked about that bright spot is only obtained whenever there is a constructive interference. Yes or no? Bright spot is only obtained wherever there is constructive interference. Yes or no? Right? So in order to get the constructive interference, the path difference was coming out to be n lambda. If you guys remember, if you guys have seen the previous video, then you guys remember the path difference is supposed to be n lambda. N lambda means what? The first path difference will be lambda, the another will be 2 lambda, 3 lambda, and so on. So basically you guys can very clearly see, अब यहाँ पे इस formula को check करो, right? Just check the formula. Del x is the path difference, and that is equals to d sine theta, right? Or very simply is equals to del x. Let me take my del x to be lambda. Let me take that to be lambda, because anyway there is a constructive interference. Let me take, for time being, take it to be lambda. Okay, so I'll take it lambda. Lambda by d is actually equal to your sine theta. Yes or no? Sine theta is coming out to be lambda by d. Now what is lambda? Lambda is actually the wavelength of light, right? Okay, wavelength of light varies from कहाँ से कहाँ vary होता है, right? Wavelength of light varies from 4000 angstrom knot to 7500 to 8000. Let me call it 8000 angstrom knot, right? This means it will be 4 into 10 to the power minus 7 meter approximately, something like that. Yes or no? Right? So that is the wavelength of light. Okay, what is this d? D is basically the distance between the slit, right? And this is actually in, ये आपका मिलीमीटर में होता है. मिलीमीटर का मतलब क्या है? Millimeter means 10 to the power minus 3. So basically I can write sine theta is actually equal to ऊपर आपका 10 टू द पावर -7 है, नीचे आपका 10 टू द पावर -3 है, राइट. सो बेसिकली यू कैन राइट साइन थीटा इज इक्वल्स टू 10 टू द पावर -7 प्लस 3, और आई कैन सिंपली से 10 टू द पावर, yes, 10 to the power -4, right. That means sin theta will be something equal to 0.000 and some value, right. So I can very clearly say sin theta is approximately equal to 0. Yes or no? Sin theta is approximately equal to 0. So we have studied that when your, actually we have studied now in our optic experiment also, that for sin theta, देखो 0 is actually very small value, it's actually very small value, right. For small values of theta, we have studied, for small values of theta, for small values of theta, your sin theta can be written as tan theta. Yes or no? For small values of theta, sin theta can be written as your tan theta. Very important, sin theta can be written as tan theta, right. So take this assumption with you, take this assumption with you, assumption नहीं बोलना चाहिए, approximation, take this approximation with you and let's try to apply it here, right. Let's try to apply it. कहाँ apply करना है? We will apply it where? Yes, yeah, this term, right. Let's apply it here. Del x equals to d sin theta लिखा हुआ है, so I'll just write it there. I'll just write it now. With that approximation, I can write del x, that is the path difference, is actually equal to d tan theta. Instead of sin, I can replace, because for small angles of sin theta, for small angles of theta, sin theta can be written as tan theta, right. I hope everybody agrees with this statement, right. I hope clear, right. Okay, now if that is true, all right, okay, now let's move forward. If that is true, so I can write, very important, that I can write my del x as d. Okay, let's tan theta. Now what is the value of tan theta? Let's go back to the diagram here, right. Okay, look at the triangle. Okay, let me call this as o point, let me call this as c point, right. And that is already, look at triangle OPC, look at triangle OPC, right. Triangle OPCT, if somebody asks what is the value of tan theta for triangle OPC, tan theta is actually equal to perpendicular upon base, right. What is perpendicular is actually your xn. What is base? Base is actually your d, xn upon d. Take some seconds to understand this. I'm looking at triangle OPC, right. So let me write it here. Okay, in triangle OPC, I can write tan theta is actually equal to, yes, xn upon d, right. I hope everybody can see that, right. Go back there, xn upon d, right. Xn upon d, tan theta. I hope everybody can see that. Yes or no? Right, clear hai? Okay, so if that is true, let's move forward. So that means, put this value back in our equation, you will get del x is equals to, yes, this is d xn upon d. Yes or no? Right, d xn upon d. Acha, one more thing we have to understand. We are obtaining bright fringe, right. We are obtaining bright fringe, yes or no, right. So bright fringe, we know the path differences for bright fringe, right. So we can write for bright fringe, or I should say for nth bright fringe, right. For nth bright fringe, the path difference must be yes, must be del x is equals to n times of lambda. Yes or no? Agreed, right. So basically what we are doing here, आपको पता है you had, यहाँ पे आपके दो slits थे, right. यहाँ पे आपका screen था, right. The screen was here, right. So at the center we were getting the central bright fringe, right? So we are talking about this bright fringe, which is this distance is actually xn. We are talking about this nth bright fringe, yes or no? So something, आपका diagram ऐसे कुछ है, right? Okay, so we are saying that the distance between the central bright fringe and the nth bright fringe is actually xn, yes or no? The distance between the central bright fringe and the nth bright fringe is actually some xn, right? very very अच्छे से आप इसको ध्यान रखिएगा, right? Okay, so that means, इसका मतलब क्या है? that means that is for nth bright fringe, for nth bright fringe I can write del x is equals to, yes, del x is equals to n lambda, right? एंड अभी हम लोगों ने यहाँ पे del x का वैल्यू फाइंड आउट किया हुआ है. del x is equal to d xn by d, right? So I can write it here, d xn upon d is actually equals to n lambda, yes or no, right? Or very simply I can write xn is actually equals to n lambda d by small d. Very important, n lambda d upon small d, right? And let's, for n is equals to 1, n is equals to 1 का मतलब क्या है? n is equals to 1 is actually, we are taking, n equals to 1 is, we are talking about first bright fringe, yes or no? First bright fringe, right? we are talking about first bright fringe. इसका मतलब क्या है? ओके, ये आपका nth bright fringe था, राइट? इसके बाद आपको डार्क मिलेगा, उसके बाद आप अगेन आपको ब्राइट फ्रिंज मिलेगा. दिस विल बी योर फर्स्ट ब्राइट फ्रिंज, राइट? सो वी आर टॉकिंग अबाउट डिस्टेंस बिटवीन दिस वन and this one. This is x1, that is that distance. So this distance, this is the separation between two bright fringes, right? Basically I can say that when I say this, means this is the separation between two bright fringes, right? Separation between two bright fringes, right? And we call this fringe width. क्या बोलते हैं? fringe width. This is what you call as your fringe width. It's represented by beta, right? beta से represent करते हैं, right? So the moment I put your n is equals to 1 in that equation, I will get x1 is equals to lambda d by d, right? This is the distance between two bright fringes, or you will call this fringe width, right? You will call this fringe width. इसको हम लोग बीटा से भी represent करते हैं. So basically fringe width, this is for bright spot is given as beta, and that is equal to lambda d by d. I hope that is understandable, right? Now if somebody asks you what is the distance between your your second bright spot and the central bright spot, that will be simply equals to 2 lambda d by d. I hope that is understandable to everyone, right? Clear hai? So that is your fringe width, lambda d, capital D by d. I hope that is clear to everyone, right? Okay, if that is clear, what will happen? Note what will happen if instead of bright fringe we talked about dark fringe, right? Instead of bright fringe, if you would have talked about the dark fringe, तब मैं क्या बोलता, right? what would I have done? I would have said, right? Or I would have done, yes or no? So for that thing you have to understand, if at p point मतलब जिस पॉइंट पे हम बात करें, that means यहाँ पे आप चेक करो, ऐसा कुछ डायग्राम था, right? So this was your central bright fringe, right? और ये जो आपका जो पॉइंट है p पॉइंट पे, let's say here comes your nth dark fringe, right? Let's say here comes your nth dark fringe, right? अगर यहाँ पे nth dark fringe होता तो हम लोग कैसे इसको solve करते, right? So how would have like how we would have calculated the fringe width for your dark fringes, right? So very important, you have to understand here, right? So at that time, for nth dark fringe means there is destructive interference. Yes or no? Yes or no? Destructive interference, right? That means, what does that mean? That means we have a phase difference. We have a we have a path difference of 2n minus 1. See, अब यहाँ पे आपको 2n minus 1 times lambda by 2. Okay, so in the previous video, if you guys might be wondering, in the previous video I talked about, okay, you have to understand, when I say 2n minus 1, right, my n is actually starting from, कहाँ से start हो रहा है? n is starting from 1, right? You cannot start here by 0 से start नहीं कर सकते. Why? Because when you start by 0, the first term comes out to be minus lambda by 2, right, which we do not take, right? Now in the previous video, when I talk about destructive interference, right, उसमें मैंने बोला था the path difference for destructive interference is actually lambda n plus half. Yes or no? Lambda n plus half, right? So here my n was starting from 0, right? So n starts with 0 and the first term comes out to be lambda by 2, which is very perfect, which is correct, right? But you have to understand here, n is not 0, n is starting from 1. So if n is starting from 1, you have to modify your equation to this one, right? So here you can see, if you start your n with 1, the first term comes out to be lambda by 2, right? So both are same, right? The difference here is, if you are using this term, this is the term in which your first term will start with 0, but this is a term in which your first term is going to start with 1, right? So for destructive interference, we have to take our del x to be 2n minus 1 lambda by 2, right? I hope everybody agrees with that, right? Okay, so if that is true, right, all you have to do is now to put the value in the previous one, right? So we know del x equals to lambda by 2, and we know, one more important thing, important thing that you have to understand here is that let's say this distance, starting case में it was xn, let me call this distance to be xn dash. Okay, there is an only difference here, right? So here I will write d xn dash upon capital D, बाकी सब same होगा, and that will be actually equal to, yes, 2n minus 1 lambda by 2, 2n minus 1 lambda by 2, right? Clear hai, right? Okay, so basically you have to understand here, this is the central right fringe, right? Then comes your first dark fringe, right? And we are actually talking about this nth dark fringe, right? So this xn is actually a distance, xn dash is actually distance between nth dark fringe and your central bright fringe. Very carefully इसको समझना है, ठीक है? Okay, so let's move forward with this, right? So I can write xn dash is actually equal to d by d 2n minus 1 lambda by 2. Yes or no? I hope everybody agrees with me, right? So when I write, when your n is actually 1, right? When the n is 1, it will come x1 dash is actually equal to d by d, this will be lambda by 2, right? Or I should say d lambda by 2d, right? Now what is this distance? This distance is actually your first dark fringe and your central. So this is your x1 dash, right? Very important, right? Now when n is actually 2, right? When n is actually 2, then you will write x2 dash is actually equal to this will be yes, n is 2, this is 4 minus 2, this is 3 lambda d upon, yes, 2d, right? Yes or no? So what is this x2 dash? यहाँ पे आपके पास again you will have the first bright fringe and then you have the second dark fringe, right? So this second dark fringe का जो आपका distance है, this is your x2 dash, right? But we all know fringe width क्या होता है? Fringe width is actually the actual distance between two dark fringes, right? So two dark fringes का distance कितना है? This is actually x2 dash minus x1 dash. I hope everybody can see that, right? So basically fringe width, or I should say beta for dark fringe is actually equal to, ध्यान से देखिएगा, it's actually equal to x2 dash minus x1 dash. I hope that is clear, right? And that will be simply equal to 3 lambda d by 2d minus d lambda by 2d, right? So this is actually equals to 2 lambda d by 2d, or 2 से 2 cancel out हो गया, so you will get beta is equals to lambda d by d. Very important, right? So basically beta will be equal to lambda d by d, which is actually same as that of your for your bright fringe, right? Bright fringe के लिए भी आपको same beta मिला था, right? So what we can conclude from here? Note, you can write a note here. We can write a note here. Note, what is the note? Fringe width is same for bright fringes as well as for dark fringes, right? Take it bright or take it dark, but fringe width actually is same for both the fringes, right? Okay. Again, next thing which you have to understand here is intensity of all bright fringes is same. Let me call it, say it is some I, let me call it some I, right? Which is given by the formula जो हम लोगों ने इंटरफेरेंस में पढ़ा था, which is given by the formula I max is actually equal to root of I1 plus root of I2 whole square, right? Very similarly, you can also say that note intensity of all dark fringes is same. Again, say I, which will be given as, which is given by the formula. The formula is the same formula that we studied in the interference, that is I minimum is equals to root of I1 minus root of I2 whole square. I hope समझ में आ गया, right? So basically I hope that is full video is understandable, right? So let me just go back and do a quick revision of what we did today. We talked about young double slit experiment. This was the experiment which was actually the revolutionizing experiment in the field of modern physics, right? So basically Young did the displacement. We took a monochromatic source of light, passed through a very very thin slit, and we see this alternate dark and bright fringes, right? Which was very strange. So this explained that light does not have particle nature, but light has wave nature, which was very important to explain this fringes phenomena, right? Then we talked about constructive interference, destructive interference, how we are actually seeing this dark spot, bright spot, right? And then we try to find out the fringe width of this dark and bright spot. What was the fringe width? It was the distance between two alternate bright spot or two alternate dark spot, right? So with the study we were able to find out that the fringe width was coming out to be lambda d by d, right? This was same for your dark spot also. It was again coming out to be lambda d by d, right? So for both dark and bright, the fringe width is actually same. Intensity of all the bright fringes is same, that is I root of I1 plus root of I2 whole square. Intensity of all the dark fringes is same, that is root of I1 minus root of I2 whole square. I hope you understood the lecture. If you have any doubt, you can ask in the comment section, right? And that's all for today. Thank you and have a nice day.